So first piece of vocabulary here, an average, well, let me throw out the question to you. Do you know what an average rate of change is? It's actually an Algebra 1 topic, but I'm just going to throw it out there. Oh, go say that louder. Slope, regular old slope. This topic doesn't actually fit in with the rest of this unit. Remember how we've been doing inverses, like swap x and y and domains and f of g and all that stuff? It doesn't really fit in here, but the county says we teach it, so it's in here. This is actually a lead into a topic we do in AP Calculus as well. So if you're going on to AP Calc next year, you're going to, get this all over again. Real quick before I left a lot of space here because I'm going to draw you a picture. All I need you to do is watch. We're going to review how you do slope, regular old Algebra 1 slope. So you need 2 points. Can you give me some single digit numbers and we'll just make something up?
3, 5, 12.
12 is good. Okay. So you're going, do you remember rise over run for slope? You go up and then over, or some people say like you have to take the elevator where you're going before you can get out. Like heard that. Yeah. So you subtract your y numbers. So it would be 12 minus 3, fraction bar. And then what would go on the denominator? 5. Now, why would it be plus 2? Yeah, minus a negative. And then you would get, what is this, 9/7? So your slope would be like up 9/7. Yeah, 12 minus 3. And you didn't have to write that down. I was just showing it. Here, do you want another one? I'll do another one. Make them up all day long. Give me some more numbers. There we go. All right, so it would be 6 and then what? Minus -3, which would be plus 3. And then you'd have 4 minus 7. So you subtract the y values, fraction bar, you subtract the x values. This would be what, 9 over -3. Oh, that actually reduces. That would be -3. Or -3 over 1, you would go down 3 over 1. Slope, is this coming back to us? All right, sounds like we're all right. So we got there. So I'm going to draw a picture for this. So draw yourself a little, coordinate plane and just draw yourself an exponential graph. Draw a little swoopy thing. Because we're going to do the more grown-up version of what I just went over on the sticky note, right? So if you start with this point at x, I'm going to call this x. The point on the graph would be right there. And then the output value for that would be f of x. I realize that's a lot of symbols, but did you all come with me on that thought journey? You input x, your output is f of x. Are we still cool? All right. So what we're going to do is travel a distance down the axis, and we're going to go a distance of h. We're going to call that h. You have to call it a different letter of the alphabet. It's $1 million question. If this is x, and we go a distance of an amount h, what is this new x? Good. Okay, cool. I sometimes get a lot of weird answers for that, like x times h or x to the h. I don't know. Anyway, you just add them together. You're all with me? That sounded like that went good for you guys. So find that point on your graph. What would the output of that be? And I know it's going to look a little funny, but, go with it. Yeah, f of x plus h. If you input x, you get back f of x. If you input x plus h, you get back f of x plus h. Is everyone still with me? Again, I know the symbols look a little weird, but it's, trying to jam every letter of the alphabet in here. Now we're going to attempt to draw a straight line through these to get our slope. And we're going to recreate what we just did on our sticky note. You subtract the y values. Those are the ones I'm pointing at right here. And then fraction bar, and then you subtract your x values. Right, so your slope is, if you subtract these y values, it's f of x plus h minus f of x. Let me pull back out one of the sticky notes. On this one, that's the same exact thing as doing 6 minus -3. It's just this minus this. No different, so don't overcomplicate it, right? Fraction bar, and then you're going to subtract your x values, which would be what minus what? X plus h, good, minus x. Oops, kind of talking right at the same time. Now you should notice something that's going to happen there. What is going to happen? Yeah, these x's cancel. So you get f of x plus h minus f of x over h. This is the thing that you need to remember. That is your more grown-up pre-calculus version of average rate of change. But it's not any different than y2 minus y1 over x2 minus x1. It's just newer, a little bit more calculus-y grown-up symbols, okay? Same thing. And actually, I should have written that down here. That's your difference quotient. Difference means, oh, actually, let me go ahead and ask you, what does difference mean? Like we have sum, difference, product, like all those words. Difference means subtraction. Do you see how there's subtraction right here? And what does quotient mean? Yeah, well, quotient means divide. So that's this division bar. Which one means multiply? Product means multiply. So difference quotient, it means you subtracted and then you divided. That's just a fancy way of saying that. So all our directions are going to say is find the difference quotient for each of these. Now, instead of viewing it like a whole big formula, here's what I do. Step 1, step 2, step 3. Steps are easier than formulas. I'm not a very good memorizer. You guys paying attention back there? So memorizing a formula is not, very easy for me. I'm good with steps though. So here's step 1. Plug in x plus h. This is your step 1. Plug in x plus h. So if you plug in x plus h to this, it's going to look like that. So that's step 1. You plug in x plus h. As a heads up, this is going to look like a mess. If it looks like a mess, you probably did it right. So that's step 1. Then step 2 is minus the function. So it's minus f of x. Now you need to give hugs here because you have to subtract the whole thing. So it's minus the function. And then step 3, I heard somebody say it back there. Step 3 is the whole thing is over h. Now I will go ahead and say, a lot of people don't like writing the fraction bar over h over and over and over again for each step of this. I'm going to write it because I'm the teacher and I'm explaining it to everybody. But if you don't want to, that's okay, as long as you put it in at the end. Do you understand what I'm saying? Like, if you don't want to write over h on every single step, I get that it looks crowded. Just make sure you put it at the end. Now you're just going to algebra this and see what happens. What would you do with this 5? Yeah. 5x plus 5h minus 1. Then what? So you're distributing a negative. That's going to flip-flop all of this. So good. Minus 5x plus 1 is all over h. And then you should see stuff that cancels. Do you see anything that's going to cancel? 5x's cancel. Those are gone. The 1's cancel, those are gone. So you got 5h over h. And your last step is always to cancel out the h's. These turn out the same way every time. So if those cancel, you just get 5. Why? That should make sense. You should be like, hey, that makes sense. Look at this equation. Why is the answer just 5? It's with the x, so that means it is the slope. Do you see how this is y equals mx plus b, and that's your slope? How this would be a line? Now you can only get away with that if it's a line. If it's a curve, you cannot get away with that. But if you have something that is linear, your difference quotient is the slope. That's literally the definition. The definition is slope, all right? But for this one, I want you to not do any work. I want you to be smart and notice, hey, this is a line, and the slope is -2 is your answer. But again, that only works for lines. So listen, and I'm going to say this so it's on the recording as well. When you go to do your classwork, I think I gave you 5 of these. I'm fine with one of them being that, and you can skip all the work and just write the answer. I want you to work out the other ones. Do you understand what I'm saying? And I have the ability to go into Delta Math and see which problems you did. So one, you can do that. The others, I want you to actually do the problem. All righty? Now, you can't get away with that for this problem. How come? Yeah, it's a parabola. It's not a line. Okay, so step 1, plug in x plus h. So that is going to look like this. However, what do I always tell you to do when you have an x plus h squared? When you have something squared, what do I always coach you to do? Good, just write it twice. Instead of writing the squared, just write it twice. And then -2. These problems are actually very user-friendly because if you don't get things to cancel, then you know you have done goofed. Like stuff will cancel out with them. So that was step one. We plugged in x plus h, just instead of writing squared, we wrote it twice. It's a twin. Step two, minus the function, right? So x squared minus 2. And step three is the whole thing is over h. And then you just algebra it. Multiplying this out, x times x, x squared plus, so the outsides give you xh, the insides give you xh, so together is 2xh, and then h times h squared. As a heads up, you are going to do x plus h squared a lot. You would almost do well to just memorize that, okay? Minus 2. Distribute the negative. That's going to give you minus x squared plus 2. And then the whole thing is over h. Again, at this step, that's called expanding. Once you expand it, stuff should cancel. And if it doesn't, then you made a mistake. You can catch your mistakes with this. It's very user-friendly. So call them as you see them. What is going to go away? X squareds are gone. And the 2's are gone. Now, this one's a little bit more complicated than the other one because it had a squared in it. Out of the 2 terms that are left, what do you see that they both have? H. So we are going to GCF the H. We're going to greatest common factor, like undistribute the H out of there. So that would leave you with what? 2x plus h. And then the last step is always that the h is canceled. That will be the last step of every single one of these. And so your final answer is 2x plus h. And again, what we're finding is a formula for the slope of the graph, right? This one's a little bit more complicated. Why? What has it got? There's 2 variables in it, okay? What is step 1? Plug in x plus h. So it's x plus h squared, but you can just go ahead and write it twice. Plus 4 x plus h. When there's 2 variables in there, you plug the x plus h into both of them. Then what is step 2? Minus the function, like that whole thing. Minus, give it a hug. And then it is all over h. So again, this first part, you're going to do that a whole lot. It's not any different than what we did up here. It's going to be x squared plus 2xh plus h squared. You would do well to almost just kind of know that one because you're going to do that a lot. All right, and then what? Just continue with your algebra skills here. Plus 4x plus 4h. All right, perfect. Over h. And again, if you don't want to write the over h every single time, this is the step where you have to bring it back. Do you see what I'm pointing at? When you factor out the h, I want to see fraction bar h because that's the way you're showing me. Do you understand what I'm saying? Showing me that they cancel. If you don't want to write it on this step and this step, that's fine. But the third step, you have to bring it back. Okay. All right. What cancels? We should get a bunch of stuff that cancels. All right. X squareds are gone. 4x's are gone. Anything else? And then you will always, these turn out the same way every time. You're going to take out an h, that will leave you with 2x plus h plus 4. And that's the step where if you haven't been writing it, I want to see fraction bar h because the next step is where they cancel. So I need you to show me, hey, those cancel out. And then 2x plus h plus 4 is your final answer. How do we feel? It's not that bad, right? It's just a bunch of algebra. Yeah. Question. Hold on a second. Yeah, can we finish the last problem? Okay. So I'm going to hit pause. I want you guys to try that one with your group, and then I'll go over it. So when you do the first step, when you plug in the x plus h, I'm going to leave the 3 there. What did we say x plus h squared was? Because you kind of would do well to just know that one. It's x squared plus 2xh plus h squared. And then you'd have plus 6 x plus h and then minus 1. I'm going to hit pause again, but that would like get you started. Time. Hey, guys. So I got you started on that first step. We plugged in x plus h. X plus h squared equals this. Again, you do that a lot. What comes next? What am I going to have after this? Minus the function. Here, and I'll show you what I mean without writing the h. Like if you want to not put that, that's okay. So now you're going to distribute the 3. 3x squared plus what? Get 6xh plus 3h squared. Good. Distribute the 6 plus 6h minus 1. And then you would distribute the negatives. So these are all going to flip-flop. It'll look like that. Wow, I barely fit that in. All right, now stuff should go away. So what? Hopefully a lot of things. All right, 3x squareds are gone. All right, 6x is gone. And the 1s. Everything else should have an h in it. These are our 3 terms that are left. So when you factor out an h, what's left? 6x plus 3h plus 6. And again, if you weren't writing over h, this is the step where I want to see it back because I want you to show me they cancel. And then what's left is your final answer.